Hello, welcome to this Sci Ed Co video. As with all our videos, our content is designed to meet the criteria of the AQA GCSE Science courses. However, much of the content in this video is also suitable for other specifications such as OCR or Edexcel. Today, we're going to be looking at atoms and atomic structure. According to the specification, you need to be able to identify subatomic particles and be able to draw the first 20 elements from the periodic table. Before that, however, let's look at what an atom is. Everything in the universe is made from atoms. In fact, you could say that atoms are the building blocks of the universe. From stars and planets right down to hamsters, they are all made from atoms. Let's look at another example. Here is a fork. Now, a fork, just like a hamster, is made from atoms. In lower school or at Key Stage 3, you don't usually learn about atoms. Instead, you learn about particles. Now, if we zoom in with a bit of magic, we should be able to see particles. Here you go. They are basically circles. At Key Stage 3, you learn that everything is made of particles. At GCSE, we don't really use the term particles. Instead, we use the term atoms. Now, just to recap, you may remember that if a substance is made out of one type of particle, we call it an element. For example, a solid gold brick will only be made out of gold particles. Mixtures are substances that contain two or more particles that are mixed together. The important thing to remember here is that they can be separated. Finally, compounds are two or more different particles that are chemically bonded together. They can only be separated by a chemical reaction. Now, if you don't remember these terms, don't worry too much. We will look at this again in another video. The point of looking at this is to show you that at GCSE we use the term atom instead of particle. So for example, an element is made out of one type of atom. A gold brick is made out of gold atoms. So, what do atoms actually look like? Here you go. This is an atom. It's a sodium atom. All atoms have the same basic structure. Atoms are made from subatomic particles. The three subatomic particles are protons, neutrons, and electrons. In the centre of an atom, we find the nucleus. The nucleus is made from protons and neutrons. Orbiting the nucleus, we find electrons. Electrons orbit the nucleus in electron shells. In my example here, sodium has 3 electron shells. In the first shell, we can see 2 electrons. These are represented by purple crosses. The second electron shell has 8 electrons, and the third electron shell has 1 electron. I'm hoping that by the end of this video, you'll be able to draw atoms. Let's have a more detailed look at these subatomic particles. Okay, so here we have our 3 subatomic particles. Protons, neutrons, and electrons. Each of these particles have a charge and a mass. It's important that we know these facts as they will help us to understand and draw atoms. Protons are positively charged. Each proton has 1 positive charge. Protons also have a mass of 1. Now, when we're talking about masses, we aren't talking about weight or kilograms or grams. The mass is an arbitrary number that simply allows us to quantify and compare the subatomic particles. All you really need to know is that protons have a mass of 1. Neutrons do not have a charge, they're neutral, but they too also have a mass of 1. Finally, electrons. Electrons are negatively charged. This means that each individual electron has 1 negative charge. Electrons are so small that they do not have a mass. Now, let's apply what we've just looked at to an example. One of the most important things you need to remember is that atoms are neutral. They have no overall charge. Now, this might sound odd because we know that protons are positive and electrons are negative, and that atoms contain protons and electrons. So let's have a look what's happening. On the bottom right hand side of the screen, you can see the atom lithium. The blue circles represent protons, the red circles represent neutrons, and the purple circles represent electrons. You can see the key on the table. In the nucleus of lithium, you can see that we have 3 protons. Therefore, we must have 3 positive charges. If we only had these 3 positive charges, then the overall charge of the atom would be positive. However, we know that atoms do not have a charge. This is because we also have 3 electrons, which means we have 3 negative charges. The negative charge of electrons is the same as the positive charge of the protons. Therefore, they cancel each other out, giving an overall neutral charge. This is why the number of protons in an atom is always equal to the number of electrons. At this stage, you may be asking yourself, well, how do I know how many protons, neutrons, or electrons an atom has? To find that out, we need to look at the periodic table. This is the periodic table. It lists all of the different atoms known to us. This is the exact periodic table that you will be given in the exam. I've included the link at the bottom of the screen so that you can download a copy and add it to your notes. If you look at the top of the first column, you will see the atom lithium. This is represented by the symbol Li. Let's zoom in closer. Each symbol on the periodic table is accompanied by 2 numbers. The top number is called the mass number and tells us the total number of protons and neutrons in that specific atom. The bottom number is called the atomic number and it tells us the total number of protons in that specific atom. Remember that the number of protons is always equal to the number of electrons. Therefore, the atomic number can also tell us the number of electrons. The table at the bottom right hand side of the screen lists the number of protons, neutrons and electrons that lithium has. We know that lithium has 3 protons because it has an atomic number of 3. If lithium has 3 protons, it must therefore have 3 positive charges. It must also have 3 negative charges and so have 3 electrons. Now, to work out the number of neutrons, you simply need to subtract the atomic number away from the mass number. So, in this example, we would subtract 3 away from 7. This would give us 4. Lithium has 4 neutrons. While it's easy to work out how many neutrons an atom has, it's important that you try and understand how we work it out. Protons and neutrons have a mass of 1 each. Electrons are so small that they do not have a mass. Therefore, when we look at the overall mass of an atom, by looking at the mass number, we're only talking about protons and neutrons. In this example, the mass number is 7. Now, we know that lithium has 3 protons because its atomic number is 3. So if lithium has an overall mass of 7, and 3 of those masses come from protons, this leaves 4 masses unaccounted for. The only place that those masses can come from is from neutrons. Remember, electrons do not have a mass. At the table at the top of the screen, it shows each neutron has a mass of 1. Therefore, it must be 4 neutrons because we have 4 spare masses. At this point, I suggest that you rewind the video a few seconds back and make sure that you understand how we can calculate the number of protons, neutrons and electrons using the information from the periodic table. Okay, I'd like you to put your newfound knowledge to the test. Here, I've listed 3 atoms, carbon, sodium and calcium. For each atom, I'd like you to write down the number of protons, neutrons and electrons. Please pause the video now before we go through some of the answers. Right, let's see how well you've done. Carbon has an atomic number of 6. This means that it has 6 protons. Remember, the number of protons always equals the number of electrons, so that the charges are balanced. In other words, if we have 6 positive protons, we must also have 6 negative electrons. Finally, if we subtract the atomic number away from the mass number, that is 12 minus 6, we are left with 6 neutrons. On the screen, you should also be able to see the correct answers for sodium and calcium. Please pause the video here while you correct your answers. This is the atom that we looked at earlier. So far, we've looked at the 3 subatomic particles and looked at where we find each of those particles. We have also explored how we calculate the number of protons, neutrons and electrons an atom has by using the periodic table. Now let's investigate how we draw atoms. Electrons orbit the nucleus in energy shells. In your exam, you'll be expected to be able to draw the first 20 elements of the periodic table. To do this, there's a special rule you have to remember. That rule is 2882. Now let me explain it. In the first electron shell, you can fit a maximum of 2 electrons only. In the second electron shell, you have to fit a maximum of 8 electrons. You can also fit 8 into the third shell. In the fourth shell, you can only fit a maximum of 2 electrons. It's important to remember that the previous shell must be full before starting a new shell. Now, let's have a look at some examples using this 2882 rule. In the first example here, we have carbon. Carbon has an atomic number of 6, therefore we know that it must have 6 electrons. In the first shell, we can put 2 electrons. If we had 6 electrons to start with, and 2 have been placed in the first shell, we are left with 4 electrons. These remaining 4 electrons are placed in the second shell. We would say that the carbon atom has an electronic configuration of 2, 4. You might notice that the drawings of the atom on the screen are much more basic than the previous examples. When drawing atoms, you only need to draw the nucleus as a dot. You can represent electrons as crosses or dots. In the second example, we're looking at sodium. Sodium has an atomic number of 11, therefore there are 11 electrons. Using the 2882 rule, we have put 2 in the first shell, 8 in the second shell, and 1 in the third or outer shell. We would say sodium has an electronic configuration of 2, 8, 1. In the last example, you can see that calcium has an electronic configuration of 2882. All of the shells are full. Now, I'd like you to have a go at this task. Using the information from the periodic table, I'd like you to list the number of protons, neutrons and electrons for each atom. Then, try and draw each of the atoms as I showed you on the previous screen. If you can, also try and include the electronic configuration. Please pause the video here. Right, let's have a look at the answers. As you can see, lithium has an electronic configuration of 2, 1. Fluorine has an electronic configuration of 2, 7. And chlorine has an electronic configuration of 2, 8, 7. Please pause the video here if you'd like to review your answers. Unfortunately, we've come to the end of this video looking at atoms and atomic structure. Underneath this video, you'll find links to tasks, activities and past exam questions to help you prepare for your exam. As always, thank you for using Sci Ed Co videos. If you have any feedback or suggestions, please leave a comment at the bottom of the video.